Hello, this is going to be your Chapter 4, 5, and 6 test review. I can see two issues that on the copy that I'm going to be using for this video. One, it says Chapter 5 and 6 test and not 4, 5, and 6. It also says Math 151 instead of 152. That's what the course used to be. And number 4 should not be in there. It kind of snuck in there, so I will take number 4 out and put in something related to finding a probability like on 5 and 6, so that way you still have enough questions so that it's only worth 4 points a question. Puppies are currently sleeping, so we might be able to make it through this video without a racket. Let's see what happens. We'll go back and forth between the PDF, Smart Notebook, and the calculator. So I decided to go with a video instead of a hard copy that you could print out. Let's start with number 1. You'll see that there's going to be a couple of multiple choice questions as you go through this test, like on the other test. First one says there's a class of 67 women and 12 men. A student is selected at random. What's the probability a student is a woman? Well, we need our sample space. I have 67 women and 12 men, so I have 79 people altogether, and I want to know the probability that we are looking at just women. And so I have 67 women, so then it must be, I didn't see that, 79 right there. C, 67 out of 79. Not too bad. Data below represents the income levels of members of a country club. Find the probability that a member earns at least 88,000. So 88,000 or more. So that one's 88, that one's above 88, this one. I'll go through and just highlight the ones that are above 88, at least 88,000. So that or more, we're going to count those. It looks like we have a pretty good chance, right? Out of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of the 20. And you can use your calculator to help you out. 14 divided by 20, about a 70% chance, so D. Flip a coin twice. What's the sample space? Well, if you have 2 things that can happen on the first attempt, heads or tails, and 2 that can happen on the second, then you better have 4 things in your sample space. So A and B right away are too small. We can use a tree diagram. So I can have a heads or tails on the first flip, pick the coin up, flip it again, or flip a different one, doesn't really matter. And it could be heads, tails, heads, tails. So I'm talking about a sample space of heads, 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 tails, tails, heads, or tails, tails. And let's see if we can identify that one. Looks like it's letter C. How about letter C? Sometimes they're a little hard to read. This one has HT twice. That order does make a difference, so C. Odds against, that's the one that we're going to skip, so ignore this one. Spinner has equal regions. That's important that they're equal. Number 1 through 15. What's the probability that it will land on an even number or multiple of 3? So probably the easiest way to do this is to actually write out the numbers. It may seem a little silly, but it's going to be the easiest way to identify who's an even number. So let's go through and find our evens. 2, 4, 6, 8, 10, 12, 14. And then we want multiples of 3. So 3, 6, I already counted that one. I don't need to do it again. 9, 12, already counted 12, so I don't need to do that again. And then 15. So out of the 15 numbers, I have 3, 6, 10, or also known as 2/3. Let's see how they want it. Reduced as a 2/3, so D. Card is drawn from a well-shuffled deck of 52. I want an ace or a 9. Well, I got 4 aces. Or means add. There's 4 9s. You can't be a 9 and an ace at the same time, so I don't have any overlaps. Those two are mutually exclusive, so that's 8 out of 52, which will reduce all the way down to 2 out of 13. study conducted at a certain town shows 59% of the graduates find a job in their chosen field. Find the probability that at least one finds a job in her field if, or his field, if I have 6 people that are randomly selected. So at least one is the opposite of none. That's important. So at least none is the opposite of none. So if we have 6 people, it could be 1, it could be 2, it could be 3, it could be, right? So it could be all of these different combinations of people, but it can't be the none because I want at least one. So it's going to be easier to find, well, what's the probability that nobody finds a job? Well, if the probability is that 59% that they will, then that means it's a 41% chance that they won't. And I want that to happen 6 times. So I say, hey, did you get a job? No, 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 right? So 6 people saying no, and the probability that they say no is 41%. And so the probability that all 6 of them don't find the job is 0.0047 blah, 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 blah. I want the opposite of that. 1 minus the at least 1. And I get 9952, which looks like we're going 3 decimal places for just a 995. You can use a binomial distribution since it's a yes-no question. This is probably the most direct route. Library has 7 books to give. They're choosing out of 16 titles. Every book has to have a different title. How many selections are there? Now, if you're putting books in a bag to bring to the library, it doesn't matter if you put the book in first or last, the book's going to the library. So this is an order, doesn't matter. So that means it's an NCR. So I go to the calculator. I have 16 books that I'm choosing from. And I go math over to probability down to NCR. And I want to pick 7. How many different combinations are there? 11,440. B. How many 3-digit numbers can be formed if I have 7 numbers and I can't repeat? Order is important with numbers, right? 1, 2, 3 is a different number than 3, 2, 1. So this is important. And so this is out of my 7 numbers. I'm going to pick 3. So NPR. So 7 math probability number 2. Pick 3, 210. B. Moving right along. Into chapter 5. In a certain town, 30% of adults have a college degree. Use the table below to find the distribution for the number of adults who have a college degree. All right, your mean or your well, it doesn't actually, oh, here it is. There it says find the mean. The mean is your expected value, and your mean for these probability distributions is x times p of x. But it can be a little annoying to do it by hand, so probably the easiest way is to go into Stat Edit and put your data in. Since you're going to be typing it in anyway, you might as well make your life a little bit easier. Oh, I suppose I didn't have to delete that. So 0, 1, 2, 3, 4. Put in my p of x, 0.2401, 0.4116, 0.2646. 0081. Let's make sure that we're, oops, good thing I checked. 0081, 0756, 222. Looks like we're good. And I'm going to go out to the main screen, and I need to link these together because it says, all right, like 41-ish% of your numbers are a 1. And so you could like pretend and say, oh, I have 10 numbers, but you can't write 41% of a number, right? So it just doesn't really work out that way that you can write 1% of a number. So we'll go to Stat, over to Calc 1vars. Now my screen looks a little different than the newer versions. I need to put in second 1 for an L1. That's going to be your list. And then I need to put a comma where in the new calculator you just go down to frequency and say second 2. and then hit enter twice on a new calculator, once on the old, and there he is, 1.2. Hey. Find the standard deviation. We're going to do the same exact thing. Stat, edit. I'm going to change my P of X's here. And I'm going to link my table again. So stat, calc 1 vars, L1, L2. They're still in there from before, so you don't have to retype in L1 and L2. It will know that the list is updated. And I have a 1.56-ish. Yep, there we go. A. Assume that I have 14 babies that are born, and I counted up the number of girls. What's the probability that I have 3 or less girls? So I just need to add up these probabilities right here. So 0.022 plus a 0.06, 006, 006, and a 0.00, too many O's, 1, and it looks like we have none of those. 9. I don't see it. It should be 0.029, but it looks like I might have changed this question and I don't have any of those options on there. So I have another thing that I have to update for you. 28-year-old man pays $179 for a 1-year life insurance policy with a coverage of $90,000. So if the probability that he's going to live through the year, because stats is so upbeat, is 9994, what's the expected value for the company? So the probability that he's going to live is 9994. So that means, unfortunately, not live is going to be 0.0006. So there is a very high chance that they're going to get to keep this guy's $179. 0.9994% chance that they get to keep the 179, but that's not the full story. There is also a very small chance, 0.0006, that they're going to have to pay out $90,000, which is bad news for them. Well, I suppose it's bad news for everybody, because then that $179 is not going to cover the $90,000. They're going to have to take a loss. So the expected value is not just how much will I be able to keep, but I also have to take into the consideration the chance that they may not survive the year and I have to do the payout. And $125 is what we're looking for. So A. In a certain college, 33% of the physics majors are ethnic minorities. If 10 of the students are selected at random, find the probability that no more than 6, so 5 or less. Oh, well, no more than 6. I would say 6 or less are ethnic minority. So this is going to be a binomial. So it's like, yes, you're minority, or no, you're not. So I'm going to go second vars, no, binomial PDF, and I'm talking to 10 people on the probability that their minority is 0.33, and I don't have it exactly, so I have to just leave the R blank or the X blank. And I'm going to get all of these values. So this is kind of like our Plinko lab where you said, well, I can go left or right 12 times. What are all the different combinations? I'm going to store this in L2. So now when I go into set edit, all my probabilities are there, and I want to count up from 0. So 0, 1, 2, 3, 4, 5, 6. And I want 6 or less. So I need to add up these first 7 numbers, which is not a whole lot of fun. I'm going to see if I can pull up another little calculator here. I don't know why it always opens up twice. So 0.01823 plus 0.08978. $98144 Well, it looks like I might have rounded somebody incorrectly somewhere along the way, so we're going to go with B. Another way that you could do this, if you're comfortable with the calculator, is to go into second distribution, binomial CDF. Binomial CDF is cumulative, and so what it will do is it will add up from the 0 to the number that you put in. So I can put the 6 in here, and you could see that it's a 981. They have it as a 982, so we have a couple little issues with our key here. Next question. Certain chain of a coffee shop has a 55% recognition rate. You talk to 7 people. What's the likelihood that exactly 4 know? So that means that you are going to be able to go ahead and put in a number. I'm going to go into StatVars binomial PDF. I talked to 10 people, 55% probability that they'll recognize the brand. I want to know exactly 7, and if you have an exactly 4, and I'm talking to 7, 10 was the last question. 292, 292, C. 16. Find the standard deviation if you have N and P. Well, if P is 0.2, then Q is 0.8, and the standard deviation is N times P times Q. Take the square root. Actually, I'm going to just go ahead and use my calculator. 35 times 0.2 times 0.8. Take the square root. 2366B. And actually, I will ask you to find the mean as well. That will be the question that replaces your odds question. So the mean would be just N times P for the mean. That's all your Chapter 5 stuff, so not too much on Chapter 5. Into Chapter 6. This is a uniform distribution. What's the probability that I have a value greater than 3? So from here up. Think about slicing this into sections. There are 8 sections. You want to know the probability if you throw a dart at the board that you land from... Oh, I don't know why I did that. Oh, it does not like that. Okay, doesn't like that. You land from the 3 up. And so there's 5 over there, and 5/8 is C. Find the area of the shaded region. Oh, no, the area of the shaded region is. So this little area right here is 0.0901. I want to find out what the z-score is. Where do I put up the wall to cut these guys off? Well, inverse norm is what we use for that. But inverse norm is a little sneaky. It doesn't like to look to the right, so I'm going to have to look to the left. And the area to the left is 90, 99. And so if I go into second vars, inverse norm, and I put in 90, 99, whoops, lost the 9. I get 134. Now, if you forget that, and you just go ahead and put in the 0.0901, you'll get the right number but the wrong sign, which should make sense, right? Because if this is 0 and I'm above that, I cannot have a negative z-score. Negatives are down here. Find the area of the shaded region. I'm going from a negative 182 all the way up to, and I know it's a little deceiving, to positive infinity. That's what this random thing looks like over here. It will be much more clear if you're going to stop at a number. Second vars, normal CDF. Always CDF for normal. From the negative 182 to the 9999 for our infinity, 9656. See? Wow. I left all of these multiple choice. That will not happen on your test. See, this one's from a negative 188 to a positive 188. It's much clearer about where it's stopping. And so I'm going to say normal CDF from a negative 188 to a positive 188. 93, 99. Oh, 98, another wrong rounding. That's why I don't like the multiple choice. 21, almost there. The mean is a 15.2 and the standard deviation is a 0.9. Personal phone calls in the last 3 days were 2, 5, and 6. You want to find samples of size 2 with replacement, identify the probability of each sample, and describe the sampling distribution of the means. All right, so this one will have a box set up for you so that you know what you're looking for, and it's important that you give me this little sentence. 2, 5, and 6. So 2, 5, and 6. If I write these down and put them on a piece of paper, when I pull out a piece of paper the first time,